So this is section 6.4, talking about factoring polynomials. So the first thing we always want to look before we factor is there a common factor that we can pull out? So first thing we look for is factoring out a common monomial. So in this case, our example here, first they factored out an x, then they factored out a 3, and then simplified as best they could. So always look first for, is there something that's common in both terms? So here we've got 2x cubed minus 20x. So the greatest common monomial that we can factor out is a 2x, and we're left with x squared minus 10. So we want to think about, why couldn't we factor the x squared minus 10? There's nothing that goes into it nice and evenly. So if we actually wanted to find out what that is, if we set x squared minus 10 equal to 0, which means that x squared equals 10, if we take the square root, our solutions would be x equals square root 10. So if we wanted to factor that x squared minus 10, it should factor to become x minus root 10 and x plus root 10, based on the rule here about the difference of squares. So mostly it's just going to be practicing a lot of these. So looking at our first example here, the only common term we have is an x. So we can factor out an x. We're left with 3x squared plus 7x plus 4. Now we want to see if this inside piece can factor. Now it's hard with that 3 in front of the x squared, but it is doable, and guess and check is a perfectly valid way of factoring, as long as you're smart about it. So if we think about it, if we've got 3x squared, we know our first terms are going to be the ones that multiply to get that first piece. So 3x squared, essentially the only options we have are going to be 3x times x. So then we want to look at, well, what's our options here? We need our last terms we know to multiply to get 4. So we've got two options. We've got 1 and 4. Well, I guess technically 4. Nope, 2. Since this is positive, we know our term should be positive as well. And so multiplying to get 4, we'll have 1 and 4 and 2 and 2. So you can guess and check. If we're thinking, though, we want this middle term to be 7. Well, 4 and 3 is 7. So if we multiply with the 1 here and the 4 here, when we do the outside terms, we'll get 3x. Inside terms, we'll get 4x. And that's how we're going to get our 7x inside. So you can guess and check. Just be a little logical about it. Once you know the 3x and the x are going to be the first terms, and you know the last terms have to multiply to 4, you can plug in values, see if they work, FOIL it back out. If they don't work, they don't work. Try the next one. So keep that in mind as you're working through something like trying to factor something like that. Looking at 4b, the only term we can factor out is going to be a 4. We're left with x squared minus 3x plus 2. So looking at how we can factor this one, we want two terms that multiply to get 2 and add to get negative 3. So since they're adding to get negative 3 and multiplying to get positive 2, we know that both of these should be minus. And so thinking about it, 2 and 1 multiply to get 2 and add to get negative 3. So that's our factors there. 4c. Well, looking at this one, we can factor out a 2x. We'll be left with x squared minus 4x plus 4. So looking inside at our factors, we want two terms to multiply to get 4 and add to get negative 4. That would be negative 2 and negative 2. If you want, then we could write it as 2x times x minus 2 squared. 4d, common terms we can pull out is 3x. We're left with x squared minus 9. If we want to factor this all the way out, this x squared minus 9 is a difference of squares. We're going to talk about that here in just a second, but it is a common pattern you need to know. We've got two perfect squares and we're subtracting them, the difference of squares. It's going to factor to become x plus the square root of the number and x minus the square root of the number. So that'll become 3x times x plus 3, x minus 3. So a couple special factoring patterns. Again, the difference of squares, that's one you'll see a lot and you should already know and be able to recognize. A couple other perfect square trinomials you'll see often is this one. So if you've got two perfect squares in your sum, it's probably going to become something squared. Some other factoring patterns we're going to be using a lot here. So sum and difference of two cubes. So if you've got two things here that are cubes, we've got the special patterns that happen. So if we have a cubed plus b cubed, we have to find out what a and b are. Take a plus b, and then a squared minus ab plus b squared. Down here we've got a minus b, and then you'll have a squared plus ab plus b squared. So notice the signs of the middle terms are the opposites of in the original polynomial. So since we're adding in this one, the sign on this middle term is minus. If we're subtracting in the original, we're adding in this one. So one thing to notice in the new factoring patterns, the quadratic, so that's this piece here, is irreducible. So that means we can't factor it any further. So here in A, we found this one's actually a sum of cubes. Each of these are perfect cubes. These are good things you need to learn to recognize. So 27x cubed is the quantity 3x cubed, because 3 cubed is 27, x cubed is x cubed, 64 is 4 cubed. So once you know a and b, a is 3x, b is 4, you can plug it in. So a plus b, then you'll take that squared minus, again, it's opposite, the product plus b squared. So then this would be the factor of 27x cubed plus 64. So here in B, we've got 8x cubed minus 27. We've got another difference of cubes here. Sorry, this one's a difference. The last one was a sum. 8x cubed is the quantity 2x cubed, because the cube root of 8 is 2. Cube root of 27 is 3. So we'll take a minus b, our first term, 2x minus 3. We square a, so 2x squared is 4x squared. Multiply 2x times 3 is going to be 6x. Again, it's positive. Plus b squared, so that's 3 squared, which gets us to 9.